Welcome to the session on forces and motion, forces as vectors. The objectives for this session are to calculate resultant forces by adding vectors. Forces can be written as vectors using IJ notation or column vectors. So for example, the vector minus 3, 4 can be written as minus 3i plus 4j. Suppose two forces AI plus BJ newtons and CI plus DJ newtons are acting on a particle. The resultant force is AI plus BJ newtons plus CI plus DJ newtons. As shown, we can group the i's together to give A plus CI and group the j's together to give B plus DJ. If the resultant vector force is 0i plus 0j, the particle is said to be in equilibrium. So let's take a look at an example. Consider four forces acting on a particle, namely these. If the particle is in equilibrium, find the value of P and Q. So let's solve this. As the particle is in equilibrium, we have that all the I values, or all the forces in the I direction added together equals 0, and all the forces acting in the J direction added together equals 0. And so we can solve for P and Q. The first equation implies, after tidying up, that P equals minus 5. And the second equation, after tidying up, implies that Q equals 10. A unit vector can be used to represent vectors in two dimensions. A unit vector is of length 1. Unit vectors along the x and y axes are denoted by I and j respectively. So I equals 1, 0 and j equals 0, 1. Here's I and here's j. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. A particle is acted upon by three forces, as shown. Work out the resultant force R. So let's solve this. We add the forces to find R. Adding the I values together gives us I minus 2i plus 4i newtons. And adding the J forces together gives us minus 2j minus 3j plus 7j. And tidying up gives us 3in plus 2jn. So the resultant force is 3i plus 2jn. And the resultant force is as shown in the diagram. In part B, we are required to find the magnitude of R. So from part A, we have the value of R, which is 3i plus 2j times n. Therefore, using Pythagoras gives us that mod R equals the square root of 3 squared plus 2 squared, which is root 13. And now let's have a go at part C. We are required to find the bearing of R. So let's solve this. From part A, we have that R equals 3i plus 2j n. Therefore, we have that tan theta equals 2 over 3, opposite over adjacent. This implies that theta equals 33.7 degrees. And so the bearing is 90 degrees minus 33.7 degrees, which is equal to 56.3 degrees. And finally, for part D, we are asked to describe the motion of the particle. So let's solve this. From part A, we have the value of r, which is 3i plus 2j times n. And from part B, we have that the bearing is equal to 56.3 degrees. Therefore, the particle is accelerating in the direction of the resultant force. This brings us to the end of this session. If you have understood its contents, you should be able to calculate the resultant forces by adding vectors. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.